We're going to use derivatives to find the maximum and the minimum values of functions. So we might build a function that can tell us about profit, and then we use the features of derivatives to help us figure out where we maximize profit. So the basic procedure is going to be one of finding particular places in our input variable where certain features of our derivatives are met. So the big things to appreciate are if we've got some function, right, some function of x, when we take the first derivative, f prime of x, we look at some particular value and then we ask, is this greater than 0? Is it less than 0? Or is it equal to 0? So if we have something like this, then our function is moving up, right? As we increase x, this tells us that our output is getting bigger. If we have a negative value, it means we're looking at a downward sloping function, and if the slope is 0, then at least around the particular value of x we're thinking about, we have a slope that is flat, and that means that we must be at some point that's going to be interesting. So let's say we're looking at the case of x squared. F prime of x squared is just 2x. And when we ask, well, where is 2x equal to 0? Well, we know that it's at x equals 0. So for the function that looks like this, we can see f prime of x is equal to 0 down at the bottom. It's positive over here, so 2x, if we plug in, say, value of positive 5, our slope is going to be positive 10. And over here, we're going to have a negative slope, right? So f prime for, say, negative 5 is going to be negative 10, 2 times negative 5. So the first thing we get out of the derivative is whether our function is increasing, decreasing, or not changing around a particular area. The next thing is looking at the second derivative, so f double prime. Now let's take this one, and in this case, it's just a constant 2. So the question for here is typically going to be, is this positive, like we've got here, or is it negative? When we have a positive second derivative, that means our first derivative is getting bigger, which means, let's say we're looking at this particular point. Right? So we're looking at f of x equals x squared right around x equals 0. We know that the first derivative is going to be equal to 0, right? We're right at that point where we're bottomed out, which is going to be our minimum in this case. Then we look at what happens with the second derivative, positive 2. Okay, well, let's figure out what that means. That means that from here, where we've got a slope of 0, as we increase x, we're going to be moving to a more positive slope. So we go from 0 to something bigger than 0. What that means is if we're flat and then we're going to be increasing, that's indicating that we're looking at a minimum. So if we were to say, flip this whole thing, say negative x squared, our first derivative is negative 2x, our second derivative is negative 2, that tells us that we're starting from a flat point and we're moving to a smaller slope. Smaller than 0 means we're looking at a negative slope, which means it looks like we're looking at the top of a hill. So this is the basic procedure. It's relatively simple, except that you've got to get it loaded into your brain. So what the derivative tells us is, are we decreasing, are we staying the same, or are we increasing? And if we're looking for a maximum or a minimum, we're going to be looking for a spot where we don't want to increase x anymore, because that would mean going past our maximum or past our minimum if we're looking at a minimum. Right? So we're looking for f prime equals 0, and then we solve for x. We say, where is that the case? And then we check the next thing, which is what's going on with the second derivative. And that's going to tell us, are we going from a point where we've flattened out, where we've reached our top or bottom of the function? Are we moving to a spot where our slope is getting smaller, i.e. negative, which would mean we're looking at a maximum? Or is it getting bigger, like we had when we had positive x squared, in which case our slope goes from 0 to something bigger than 0, which means we're looking at probably a minimum. Now, there are more aspects to it than that. This is just kind of the very simple version, but this really captures all of what we need to know to find maximum values and minimum values most of the time. The rest basically boils down to practice.